So thank you so much for inviting me for this conference talk. Like very similar to the last speaker, I just came 2 hours back. My flight landed and I went straight to the venue. But super excited to be talking about observability in the context of MLOps with the help of tools like Prometheus and Grafana. Now, of course, a lot of people might assume MLOps to be a role of a DevOps engineer. And of course, we are at SREcon. So how does MLOps relate to SREs? So what I like to introduce is machine learning reliability engineering in the context of SRE. So something like MSRE. And the reason why this is happening is because a lot of the responsibilities that SREs will probably take up in context of working with machine learning, it will be some of these ones that are highlighted. And of course, we'll be looking at all of these. And these primarily relate to the fact that as SREs, you're looking after the infrastructure serving up these machine learning models. And you're also regularly taking a look at how is the compute, memory, the latency in adherence with these machine learning models that are running in production. Because one of the most important concepts within machine learning, and especially when you're serving machine learning in your prod environments, is that does it perform good? Because a lot of times when data scientists and machine learning engineers are writing these models locally, it might work well. But a lot of times we see that the model does not actually serve that well when exposed to a production environment. And we'll be looking at some of the reasons why that actually takes place and how you can effectively monitor those situations and be able to tackle those by using tools such as Prometheus and Grafana. And just as a quick side note, I just wanted to know how many of you have actually interacted with machine learning models or have dealt with MLOps. So I see a few hands raised. So I hope that from today's talk, you get more motivated and do not have this doubt in your mind that machine learning is only for machine learning engineers and DevOps or SREs cannot handle that, because that's one of the biggest myth that I personally also come across. So I hope that that myth is also broken from this particular talk today. So, talking about general software engineering, right? And if we look at monitoring from the concept of general software engineering, of course, there are the SLOs that need to be maintained. There's also monitoring of the system failures that might come up in standard software development. And we'll see that how, from a machine learning perspective, some of the things that we deal with monitoring regular software are very similar in nature. But of course, there are certain other things that really make machine learning monitoring a lot different in comparison to standard software monitoring that we do on a regular day-to-day basis. And before that, I'd like to just have a quick glance of the standard machine learning lifecycle for those folks who might not be aware of it, or just to kind of recap what we usually do whenever you're dealing with machine learning systems. So normally we'll start with some data, we'll clean that data, and then we will do some feature engineering. That means that we'll select those particular features from our data that are most applicable for the type of problem we are trying to solve with the help of machine learning. Then we'll start with creation of our model. We will train that data with our model, using our model. And once the model has been trained, we'll just do some basic validation checks with some dedicated validation data sets that we have created to ensure that our model is performing well. And that's when we'll basically go ahead and productionize our model. Now, once the model has gone into production, you'll deploy it. And then, of course, like with any other software, you will continuously monitor and you'll set up observability metrics to ensure that the model is performing well or not. Now, this is the key challenge where we'll be introducing the concepts of how monitoring from a machine learning perspective actually comes into the picture. And what are some of the key challenges that we face from a day-to-day basis when we're dealing with machine learning in production. So, of course, as I mentioned, that there are some key challenges that we face when it comes to monitoring in the context of machine learning. And we'll be looking at what some of those particular contexts are. Now, edge cases are a very big factor when it comes, because normally when we are dealing with the data sets that are usually in our training data set, those are very limited in nature. But when your model gets exposed to production environment, there could be a lot of edge cases in your data because the model was never exposed to those type of data sets. And that can actually lead to inaccurate predictions. Now, this is the funny bit that when a normal regular software engineering system goes down, you can immediately see that there is a downtime, right? I hope like everyone might have experienced that when they are logging those metrics. But the thing with machine learning is that everything will look normal to you. You will get regular predictions, you will get regular metrics, but the key challenge is that you're not sure whether those predictions that are coming up are those accurate or not. And that's the biggest key difference when it comes to the core difference between monitoring ML models and your regular software. Because you'll get this regular metrics that you get, but we need to ensure that those predictions that you're getting, the model evaluation, the model performance is actually good enough or not. So there might be edge cases. And one of the other very important key factors that we commonly face is that the data distribution has actually shifted. So what that means is that the type of data on which you basically trained your model, that will gradually shift. And if you're coming from a machine learning world, you might have heard of things such as data drift. And again, if you're not from a machine learning system background, that's totally fine. Data drift is a very common machine learning problem that essentially degrades the model performance over time. And this is very commonly faced when we are dealing with production-based systems. So as data scientists, you have to continuously iterate over your model to ensure that this data drift problem does not become a huge issue. So as SREs, you just have to report that, yes, data drift is actually taking place, and that will be taken care of by the machine learning engineers to ensure that the model performs well. And of course, sometimes what might happen is that the model that you might have configured in your local environment might be misconfigured when you're putting it in a production environment. So some of the environment variables that you might be using, that might actually cause degradation of your performance when you're especially dealing with your production systems. And of course, as I mentioned, that the model will still make a prediction, but we're not sure that whether it is actually a useful prediction or not. And that's what is the key difference in comparison to standard software. Now, the question comes that what type of things will we monitor? Now, two of these aspects, system metrics and resource metrics, I hope like a lot of you might already be aware what these are. But what we'll introduce specifically in context of machine learning monitoring is the model metrics. Now, of course, before that, we'll just look at system metrics. So that means we're looking at the request latency, the body size of the requests that are being sent, the error rate, and all these are pretty common if you are using Prometheus from day-to-day basis. Similarly, we are looking at the resource metrics, CPU utilization, and memory utilization. And these, of course, play a very, very important role from machine learning perspective, because typically large machine learning models take up a lot of compute. So if you're seeing that your CPU utilization is going off the charts, then of course you'll have to do something urgently, because otherwise your costs running these models will just skyrocket. Because as compared to some of the standard software model, evaluating these models and running these models in production can cost up a lot. And especially because it is a lot of compute heavy, so you'll typically also be using a lot of things like graphic cards, and all those resources will actually end up costing a lot. But of course, the thing that we'll now introduce specifically in the context of MLOps and with observability for machine learning and monitoring for machine learning is model metrics. And what does that actually mean? So we want to track how does the performance of your model vary over time once it has gone into production, right? So we want to check how does the environmental changes affect your model, because once your model is running locally, once you push it into production, you want to kind of check that based on those new environment in which it is now running, how your performance of your model actually works over time. And similarly, as I mentioned, that especially when you're dealing with edge cases in production, how does the data drift, basically the term that I mentioned, data drift, or that's the distribution, change in the distribution of your data, how does that affect your model evaluation or the model metrics that you basically get? So that is what we'll basically track with the help of tools like Prometheus and Grafana, because we want to ensure that once the model goes into production, the performance score, the evaluation score that we get from our model, that consistently stays good. And if in case we see a significant drop in the performance of our model, and when we say what is the performance, that means that whatever predictions that the model are making, are those in line with the requirements that we have, right? So of course, performance degrade in context of machine learning would be that the model is making inaccurate predictions, just to kind of set that context. So this is one of the very popular, and if you carefully look at this diagram, this is one of the more popular approaches towards utilizing MLOps monitoring. So you'll see the core Prometheus server that will look at all the different logs that we get from any machine learning service that we are running. And you can use tools like Grafana to visualize those metrics as well. And of course, if you want to do some alerting, then you can use things like PagerDuty to get alerts regarding your machine learning model performance if, let's say, it goes down. And typically, since we are dealing with Prometheus, it uses time series database. So we'll see that how the performance of our model is there. As the number of requests that come in, we'll be able to view those metrics in Grafana and in Prometheus. And now I'll quickly jump into one of the demos. So I'll be talking about a demo using Fast API. So Fast API is a very popular Python framework that can be used to basically serve REST endpoints for your machine learning model. So in this case, what we'll do is that we'll create a REST API to first of all expose the model so that you can just have one endpoint, let's say /predict, that will be used for making the prediction. Then we'll basically instrument the server to collect the metrics by using the Prometheus Fast API instrumenter. So this is a dedicated Fast API-based collection for being able to take all the logs that you get from your Fast API endpoints and then push them to your Prometheus to monitor those logs. So this will be actually exposed via another separate endpoint. And that endpoint will be able to serve your logs to that Fast API. And then what we'll do is that we'll deploy the Prometheus to collect and store the metrics and Grafana to visualize all those collected metrics that we have. Now, we'll also, what we do is that Locus, we'll use Locus. So Locus is a service that allows you to essentially take, like, let's say, production data and then simulate load tests on your data. So this way, what would happen is that we'll have some initial starting data, and then we can simulate our production load that you might encounter once your model goes into production with the help of Locus. So you can run as many number of tests as you want with the help of this particular tool called Locus. Now, this is like the example of how, like, the Prometheus will basically take into account. So this is how you see that we have the time series database, and we'll have our, since this will be deployed on Kubernetes, we'll be able to discover our metrics by deploying our Prometheus-based server as a pod on our Kubernetes cluster. Now, I'll just quickly also showcase the code base that we have over here, right? So this is basically our model. So within this, we have our actual Fast API app. We'll not go too deep into it, but this is our model file that is actually having our machine learning model itself, and we'll be deploying this as a REST API. Then we have the Kubernetes where we'll be running some of the more load tests, and the load test is what the Locus will be used for to simulate our production load testing for our machine learning model. So I've recorded a demo over here, and I'll just quickly play that to kind of walk through what's happening over here. So at the start, what you see is the actual model. So if you look at this particular model directory, I have the Docker file that is essentially used for building our Fast API app. And you can see that it will be serving on localhost. And then, so this Docker file will be built. So this image that we use, then we can deploy this anywhere that we want. Now, once we have basically gone ahead and, I'll just quickly ensure, So once we have gone ahead and built our actual server, we will go ahead and expose this as a RESTful endpoint. Now, if you take a look at our Kubernetes, we have the model.yaml file. And this is the entire deployment file for our machine learning model. So in this case, we have created a dedicated service for deploying our Fast API-based application, which you can see over here. So we have the Wine dataset that we are using, and we have basically gone ahead and created a Kubernetes service to deploy this. And we have also actually created a service monitor. So this will be used to basically be able to serve our requests from the actual model itself to be logged into the Prometheus. So in our Kubernetes cluster, we will have deployed our Prometheus, and that will be up and running. We'll have the service monitor. We'll have our actual application, the model application itself, and then the Grafana. So all those will be dedicated pods inside of our Kubernetes cluster that we'll basically spin up. And in this specific example, what we are using is something called as Civo. So Civo is a Kubernetes distribution provider. You can use other types of distributions as well if you want. So this is one example that we are basically using. This one is Civo. Now, in this, what you'll see is that we have basically gone ahead and created like 4 different nodes, and we are basically deployed our Kubernetes cluster. Now, once we have basically gone ahead and done that, what you'll also see is now we'll basically go to the dashboards and we'll see the model.json. So this is the model.json file that will be uploaded to your Grafana dashboard. So you can basically set up your Grafana to view all the metrics that we want to see. So over here, we have also basically just set up some of the Grafana metrics to look at things such as the model performance itself, and then how does the model perform over time. And we'll also log some of the metrics such as what's the performance score itself, and those are being taken care of by these expressions. For example, we have this fast API regression model output, which will basically predict the output prediction that is coming from your model. So those are there, and then we have some other ones which are essentially looking at the entire distribution of the prediction over time. So these are the different types of dashboard. We have essentially configured our dashboard in such a way, and feel free to, I'll be sharing this GitHub repository with everyone. If you're interested to build this dashboard on your own, you can simply just take this JSON file and upload it to Grafana to be able to build this dashboard on your own as well. Now, once we have actually gone and done that, what we'll do is that we will basically port forward our actual data so that we can run this on the port number 8000. So once that is done, my bad. So once that will actually run, we'll port forward our data. And then what we'll also do is that we'll run our locust. So as I mentioned, that locust is primarily used for simulating a lot of the load data, right? To be able to go ahead and productionize your model and then run some production load tests on the model itself. So that is what is being handled over here. Now, once we do that, you'll be able to see these logs, and there are primarily 3 main things that I'd like to want to cover. So one of the ones that you see is the model prediction, right? So this is the model score that we are looking at, and this model score is essentially telling you how well the model is performing right now. So it's essentially looking at the predictions that the model is performing, and you get a good idea of whether your model is performing well or not by looking at this specific metric. And if you take a look at the right-hand side where you see all these different logs, these are the logs that we have basically run over the data that we have run, not just on the basic training data, but also on the production data load tests that we are simulating with the help of Locus. So over time, you will see all these metrics getting generated, and all these metrics are have been running over a period of, let's say, 2 to 3 hours, and you see that distribution of your data. And apart from that, what you also see are some of the additional requests from your service metrics. For example, the request throughput. These are, of course, not your model-based. These are your regular data, your regular requests, and you can also look at the standard CPU utilization as well for your models. But specifically, the one that will be useful for dealing with machine learning-based systems is the model metrics part, which is covered in the first part. So that is a quick demo of the Fast API, where we basically took a Fast API-based REST endpoint. We went ahead and deployed that on a Kubernetes cluster with the help of the Prometheus operator for Fast API, and with Grafana to visualize those metrics inside of our Grafana dashboard. And these will be useful in order to understand how well your model is actually performing. Now, another example that I like to quote is Seldon. So Seldon is an open source machine learning framework that is used for things such as model deployment, model evaluation, and model testing as well. So you can very actively utilize the metrics that you get from Selden to explain AI models, but also generate logs that can be again visualized on tools like Prometheus. So if you ever happen to come across working with MLOps and with machine learning systems, Selden is one of the most popular MLOps tools that you can actually use. And Selden Core is what is the main brain behind Selden, and it exposes the metrics with the help of Prometheus. So you can directly then get these exposed logs and then visualize them on Prometheus and Grafana. So here's like one example where we can quickly see the metrics being generated. So again, we'll have to set up the Prometheus operator for Selden, and then you'll be able to visualize all of your requests over here. And this is an example where we're basically making RESTful endpoint, RESTful API calls to our model service. And over time, we are seeing that how the model performance looks like in this time series visualization that you see in this particular Prometheus dashboard. And if you want to get started with it, here are some basic examples of how to basically build your or be able to fetch those metrics with the help of the Prometheus operator if you're using a tool like Selden Core. Another very popular MLOps platform is called Flight. So it's again an open source platform that is similar to how Airflow works, but it is primarily used for building machine learning based workflows. And you can also again monitor these machine learning based workflows with the help of Flight, because Flight, similar to Selden, they also expose their metrics that can again be visualized with the help of tools like Prometheus. And of course, if you want to monitor them well, you can simply expose those particular services with the help of PagerDuty in order to see whether your metrics are in sync and whether you're getting good predictions or not. So these are some of the existing toolings that you can use in order to basically get those metrics out of the box. The one that I first showcased with the help of Fast API is one that you can build on your own. But tools like Selden and Flight, they are open source tools that directly provide you those metrics. So you don't need to set up or basically create those deployment.yaml files that I showed earlier on your own. You can directly just use them out of the box. And like this is basically the link if you want to get started with Selden. And as we showed that the analytics were part of the Prometheus dashboard that we saw. With that, I'll conclude my talk and I'll be open to questions. But I hope that with this particular talk, you were able to get a context of why it is important for SREs as well to deal with machine learning models. And I'll just close with this particular statement that SREs and machine learning will work very well because we see a huge advent of AI models everywhere. So, I mean, probably in the next few years, each and every company will have a dedicated set of MLOps engineers who will be working on these machine learning models, both MLOps engineers and SREs, to ensure that we can get better predictions and we are able to optimize our costs. Because, I mean, it has to be the case that every company will have to adopt machine learning in some or the other way. So they will require dedicated hardware and the engineers who can work on these particular ML systems. So if you have not yet experienced SRE with ML, I'm fairly confident that in the next few months and years, you will get exposed to having to work with ML systems. So there is no shying away from that. Thank you so much.